2, 3. Okay, I already started recording. But anyway, hello everyone. Welcome to our January USACO class. If you haven't known already, the USACO January 2023 contest opens on the 27th of January. So that's a little bit less than 2 weeks from now. So what we'll be doing is it'll be very similar to what happened last time. I'll be going over 2 problems tonight. Hopefully you had a chance to look at them beforehand. And then what I'll do is I'll write the solution for you. And then what I'd like you to do is follow along. And afterwards, after the class is over, I'd like you to try to implement them on your own. So without looking at my code. That way you actually get the experience of like actually having done them. So like I said earlier, the questions aren't that difficult. They're from 2018. And so they're not like particularly challenging. So I think this would be a nice warm up for most of you. So yeah, let's get started. So if you have any questions, let me know. I'm going to be using Java, but if you use Python, then I guess go ahead and use it. It's just, I'm not going to be using Python. So I mean, I can't. So yeah. So I'm going to go ahead and open it. There we go. And then let me go here. Oh, wait. Oops, this is January 2019. Oops, it was January 2018 that we were about to do. Okay, so let's see. Okay, so we're going to be doing 1 and 2. So it's blocked, Billboard 2, and then Lifeguards. All right, so Bessie the cow used to have such a nice view from her barn looking across the road at a set of 2 billboards advertising delicious looking cow feed. This one of these billboards has been recently updated, so now it advertises blah, blah, blah. She doesn't like this because blah, 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 blah. Unfortunately, the remaining cow feed billboard is situated in front of the lawnmower billboard, potentially obscuring it. It says potentially, so don't assume anything. Like, don't assume that they're obscured. Like, don't assume that they're automatically obscured because you might have a billboard that looks like this. Oops, wrong button. Okay, there we go. It's that. Like, it might look like this. Like, this might be the cow feed billboard, and this might be the lawnmower billboard. So you don't know if they overlap. They might, but they might not. It says Bessie, determined to remove the offensive lawnmower billboard completely from her view, hatches a risky plan. She plans to steal a large rectangular tarp from the barn and sneak out late at night to cover the remaining portion of the lawnmower billboard so that she can no longer see any part of it. All right. So I guess they're going to, there might be 2 billboards. Let me try drawing those boxes again. So this. So pretend this is the red one is the cow feed one. And then pretend this one is pretend the red one is the lawnmower. Let me write that down, lawnmower. And then pretend this one is the cow food one. There we go. We have our nice work of art up here. We have, okay, it says, please help Bessie compute the minimum area of the tarp she will need. And then since they're all rectangular, she might need a tarp whose area is slightly larger than the exposed area of the lawnmower billboard. And it makes sense because if you have a rectangular tarp, you're going to have to, you might cover parts of the cow food one. Okay, using orange boxes or orange color on orange boxes is not a good idea. So you might conceivably have to cover part of the cow food one too, which is kind of, it's just kind of sad for her, but it is what it is. It says, let's see, she needs a tarp whose area is slightly larger than the blah, blah, blah. The tarp may only be placed such that its sides are parallel to the other billboard. So they can't be tilted, which is actually really nice for us because then you would have to think about angles and you get these interesting shapes, which I'm sure you don't want to deal with. So it says the first line of input contains four space separated integers x1, y1, x2, y2, where you know they're the corners of the lower left and upper right hand corners. These are important because if you know that they're lower left and upper right, then you have to know that they start here and then they end right here. Yes, so normally people do upper left and lower right, but I don't know why they decided to change it this time. And so the next line contains four more integers specifying the lower left hand and upper right corners of the cow feed billboard. It says the cow feed billboard may obscure all, some, or none of the lawnmower billboard. This is all coordinates are in the range -1,000 to +1,000. So I'm sure in your USACO class, at some point, your teachers might have told you, okay, well, maybe we have to do, come up with a better way rather than trying to come up with a coordinate grid that's 1,000 by 1,000. Because if you think about it, 1,000 by 1,000 is 1,000,000, and the grid is going to be pretty large. So that's one way to do it. I mean, you could come up with some nifty way to handle the coordinates, and I guess it would work really nice and well. But the thing is, you're on a time crunch. Like what I've seen from the last contest is that the first two problems are either be easy or moderately difficult, and the last one is very, very difficult. So you want to spend most of your time working on the last one. So you don't want to spend a lot of time, like you don't want to, like, I guess nobody's going to give you a Nobel Prize because you come up with this crazy new way to, do this without using a 2D array of Booleans. You're just going to waste time. So in this case, take a look at the coordinates. You could see that they go from -1,000 to a +1,000. So the absolute difference between them is 2,000. So if you do a grid that's 2,000 by 2,000, that's going to be around 4 million. 4 million, I had to write that out. And if you think about it, right, if your teachers have ever gone over memory limits here, you would know that the memory limit is 256 megabytes, which is 256 million bytes, so give or take a couple, 100,000. So you could see that 4 million will comfortably fit inside of it. So sometimes you shouldn't be afraid of making, just 2D grids and just making just writing whatever comes to your head first. Because you want to save time when you want to save time for the really difficult ones. All right, so the process is pretty simple. We're going to plot out the cow food billboard. We're going to, using an array of Booleans, we're going to plot out a cow, we're gonna plot out the lawnmower billboard first. And then we're going to plot them as truths. So like we're going to make a rectangle made out of true values, Booleans. And afterwards, we're going to blot out some of the true values by converting them back into false. And then and after that, we're going to go see if we're going to go see what the limits are in terms of like what remains after we get rid of some of the true values. I will say if you're writing in Java, you don't have to worry about the composition of your arrays. But the thing is, if you're writing in C++, you want to make sure that you clear your arrays first, because people have run into issues with uninitialized memory. That's like, yeah. So don't let that happen to you. But if you're writing in Java or Python, you don't have to worry about it. It's just I have run into uninitialized memory problems in C++, and I don't like dealing with those. But anyway, yeah, and then those could actually be fairly difficult to debug. All right, but if you're not doing it in that language, then you don't have to really worry about it. All right, so let's go ahead and work on it. So we have, let's see, we always import our two favorite imports are java.io and then import java.util. And if I make a typo or like you're like, well, there's a red squiggle under here in Eclipse, please don't hesitate to ask me. or like be like just unmute and say, hey, this is wrong, or like this is not working properly for me. Anyway, we have public class Billboard. If your teachers like you to keep it, if your teachers have a naming scheme for your classes, please follow it. Yeah, public static void main string args like that. And the first thing that we'll do is yeah, the first thing we will do is we will read the coordinates. So I will go ahead and do that. So I will int the problem is we have two sets of coordinates that sound very similar. We have x1, y1, x2, y2, but then they're both for the billboard and the cal feed. So don't get them confused, please. Like yeah, you're gonna end up with some really strange results if you if you mix the two of them up. So I'm gonna do int. Let's see. The first one I'm scrolling through the problem was a billboard. Okay, billboard x1. We will do. Oops, I need to make the scanner first. New scanner system.in. Then s.next int. And then if a pro tip, you can save a lot of time by copying and pasting. It's not a bad thing to copy and paste, especially if you don't have a lot of time. But if you're copying and pasting, please remember to copy and paste the right things and change them up properly. Yeah, so let's see, it was cow, let's see, food. You know, I just realized calling it billboard X1 doesn't really make a lot of sense. I'm gonna call it lawnmower X1, billboard Y1, billboard X2, billboard Y2. So remember, our plan is to make a 2x2 grid, very large, 2000 by 2000. And then we're gonna fill it with the truths from lawnmower X1, Y1 to lawnmower X2, Y2. And then we're gonna go back and fill it with falses for food X1, Y1 and food X2, Y2. That's pretty much how we're gonna do it. So the thing is, we could use the same logic for both, like for both fills. It's like we just have to switch to Boolean. So it's what we can do is we can make a method, but in order for us to use a method, we have to make a static field so that the method can see it too, and our main method can see it as well. So I'm going to go ahead and do that. Static Boolean field. Oops, I shouldn't. Field equals new Boolean. I'm going to make it 2001, 2001. The reason I do 2001 is because they say our coordinates begin from negative 1000 to a positive 1000, which is a range of 2000. But we'll just keep it nice and simple and do 2001. It's just in case there's an off by one error, we won't have to deal with that. Because, when you have coordinates that are based off of zeros and then some coordinates are based off of ones, it gets really tricky. So we will make a fill method, static void fill. It will take in a Boolean value that contains the value to fill. And then we'll just have it pass x1 and x2, and x3, sorry, it's a y1 and x2 and y2, like that. And then this will be a very, very simple operation. First, we're going to want to offset the x1 and y1, x2, y2. The reason is because the coordinates, if you read back in the problem, go from negative 1000 to a positive 1000. So obviously you can't access negative elements in an array. So you have to add 1000 to all of them. So I'm going to go ahead and do that. And I'd also like you to remember to keep your variables in order, especially because I have a habit of writing x1 and x2, whereas it should be x1 and y1. It doesn't matter what order you write them in, as long as you keep it consistent. And I equals x1, I is less than x2, I plus plus. And then for in j equals y1, j is less than y2 and j plus plus. We're going to fill it in. We're going to do field of I and j is equal to fill, whatever we want to fill it with. So that way we can go ahead and fill in our lawnmower area with truth. And this is the part you have to be careful about because in Java, this whole new Boolean array is filled with just falses. You're guaranteed that it's filled with falses. But if you're using a language like C++, it is not guaranteed to, unless you manually fill it with falses beforehand. It might contain a couple truths. That's what's known as uninitialized memory, and it will cause weird errors from time to time. Like, yeah, think about it as like static or like, like film grain. So yeah, that's one of the pitfalls of using C++. You don't have to worry about it with Java though. So y1, and then x2, and then y2. And then we go back and then we fill this with false, except we replace this with food. All right, so we've now set up our problem. We have our fill methods that filled in our billboards. We know that now we see what parts of the billboard are covered and which ones are not. So we're just going to do the obvious thing and then we're going to do the obvious thing and figure out where the bounds are for our X's and Y's. And I'm sure you could find a slightly smarter way to do it. Like you could start at, maybe you could be like, you know what, let me start at lawnmower X1 instead of starting at 0. But I'm just going to do it this way. Just for the sake of time. So I'm going to iterate over all of the values, which is to me kind of overkill. But again, we have some, you want to save time. And you save it by not thinking too hard. I of j. And then we will just have a couple of, variables out here that characterize where the upper left-hand corner is and the lower right-hand corner is too. So it'll kind of look like this, a rectangle, upper left-hand corner and lower right-hand corner. These corners are important because this is actually the lowest place with the lowest x coordinate and highest y coordinate. And this is the place with the, oops, wrong corner. Oops, didn't mean to erase that. And this is the place with the highest x coordinate and lowest y coordinate. But it doesn't matter how you choose which corners you choose to find. Now that I realize you could just as well choose these. This would have minimum x, minimum y, and then these would have maximum x, maximum y. So actually, I think these are slightly better coordinates to choose. So because that's minimum x, minimum y, we'll just do this. Min x equals 0, and then, oops, let's start at the largest value possible. Because if we're going to do math.min, and if it's 0, then it's not like I or j are going to be less than 0. And I forgot this should be j and not I. I'm making a lot of mistakes today. Min y equals 2001. On the other hand, we want math.max to have something to work on. So we start at 0 for max x and max y. And then we'll just do if min x equals math dot min x and then I, like that. And then basically it's pretty obvious how this problem is going to go. The thing is though, right? Maybe this is indistinguishable from a Like this is the values that we get out of here. It's going to be indistinguishable from a graph that has, let's say the billboard was actually 2000 by 2000. Like we won't be able to tell because maybe the problem did give us an enormous billboard. Like you never know. So for that reason, we have to keep a separate flag that tells us, yes, we actually found a true value that we filled in. Yeah, found a true value. And therefore, we actually have a valid min x and min y. It's not these placeholder 2001 values. If you put Boolean found, we'll start at false for now, but we will put it found equals true later on. And then afterwards, we will say that if we found a location that we can, if we found a couple of true values, so that means that we found a rectangle somewhere. That means that we could actually compute the values that we compute here are actually going to make sense. So min x minus max x, or sorry, max x minus min x is actually going to make sense. So I'm going to do that. So oh, and then system dot out dot println. Actually, wait a second. This is an older version of the program. So I'm going, sorry, older version of USACO. So I am going to have to revise this in a little bit to use the older methods. So in newer competitions, you get to use system.in and system.out.println. Unfortunately, in older ones, you do not. So we're going to have to tweak this, but for debugging purposes, it's fine to just print it out. You just don't want to submit it like this. So max x minus min x. You want to have a 1 because, again, all coordinates are kind of based on 1. So you will get slightly weird. You will get off by 1 error. So we want to offset it by 1. This is fairly common when we do things with coordinates. And if you like if you were writing this on your own and if you kept getting strange values, one thing I would suggest is just to try putting +1, -1. Look for patterns. You're like, wait, the answer to this is supposed to be 20, but I keep getting 19. Maybe I have to add 1. Maybe, yeah. And but if in this case, right, found will only be false if we don't find any true values here. That must mean that whatever cow food billboard, sorry, whatever lawnmower billboard we had here was completely covered up by the cow food billboard, like that. So that means that the area of this would be 0. So as for the modifications that we need to make, you need to put, we need to read from a file basically. So we need to put the rows IO exception here. You only need to do it for these old programs. You don't have to do it for the real contest. Like that. And then we will do print writer p equals, oops, let's call it out, equals new print writer, new file, billboard dot. And then instead of system.out.println, we will do out.println, and that'll be the end of it. All right, so this is the full solution for you. Let me make the window a little bit thinner so that you could see it a little, it's focused a little bit better. So does anybody have any questions about this? Okay, so I'll give you a couple minutes to copy this down. If you haven't, if you have finished it or if you've already done this before, move on to the next problem. Just take a look at it right before we, right before we move on. All right, so in the interest of time, I'm going to move on to the next one. I will put this code on the Discord though, so you could take a look at it whenever you like. So you don't have to be you don't have to get a job as a data entry specialist to copy it down. You could just copy and paste it from the Discord. All right. So this is the next one. The next problem is called lifeguards. It says, Farmer John has opened a swimming pool for his cows, blah, blah, blah. He hires N cows as lifeguards, each of which has a shift that covers some contiguous oops, I don't know, I scrolled up. Contiguous interval of time during the day. So for simplicity, pool is open from T equals 0 until T equals 1,000 on a daily basis. So it says each shift can be described by two integers when it starts and ends. So it says, let's see, a T equals 4 and ending at T equals 7, 3 contains 3 units of time. So that means that we would have to think of it as perhaps a number line. So if we consider this like 4, 5, 6, 7, it would cover 3 units of time. But the thing is, our arrays don't work like that. Our arrays work like the numbers go inside of the buckets, right? Actually, this is not a very good place to have scrolled that window. There we go. So you could see how in this diagram, the numbers are on top of the bars, which is how the problem would like you to imagine it. But unfortunately, that's not how our arrays work. Our arrays work by sticking numbers. Oops, I don't know why the numbers are getting so large. Okay. Ooh, okay, that's not what I wanted. Oh, there we go. They are on top of they are on top of the cells. So that means, okay, I don't like how the numbers are getting skinnier. Okay, there we go. So you could see that it would still, the 3 units are still there. But the thing is, we would start at unit 4. So and we would end at unit 7, but it's not as quite, so if we were to fill an array of 3 elements, you would have to start at 4 inclusive, but end at 7 not inclusive. So we would actually have to end at 6. So we would end at 7 minus 1. It's kind of like what substring does. Excuse me. So we have blah, blah, blah. 3 units of time. Unfortunately, Farmer John hired 1 more lifeguard than he has the funds to support. Given that he must fire exactly 1 lifeguard, what's the maximum amount of time that could be covered by the shifts of the remaining lifeguards? An interval of time is covered if at least 1 lifeguard is present. Okay. So there's a multitude of ways that you could solve this. You could see there, you have to first take in mind our ends, the size of our input and our range of input, because that gives us insights into how many, like what solutions we can make. Like if n was 1,000,000,000 and like the range was like 1 gazillion, then we would have to choose we might have to choose a slightly more efficient method. But since the numbers are so small, if you think about it, right? If we try, so the most obvious method that comes to mind is just to do what the problem asks you to do. You must fire 1 lifeguard. So why don't we try firing 1 lifeguard in the sequence, 1 out of the 100, and we see how much time is still covered. So if you think about it, right, there could be up to 100 lifeguards. When you do these kinds of calculations, always assume the worst case scenario, because they will always give you the worst case scenario. So you have 100 lifeguards. So that's potentially 100 times you have to run through the loop just to calculate what periods are covered by the lifeguards. And you also need to think about removing each of these 100 lifeguards. So that's 100 by 100, which is 10,000. So to me, 10,000 doesn't seem like a lot. It sounds like a lot if you had to do it on a pen and paper. But if you had the computer do it, 10,000 doesn't seem like a lot unless you're like, I don't know, like calculating how many words are in the Library of Congress. Like, yeah. So 1,000 iterations of a for loop doesn't sound that bad. So yeah, that's basically the idea. So the idea is that we're not going to do anything fancy. We're not going to do anything crazy. We're the simplest solution possible. then again, it's in the for the sake of time. You don't want to spend an hour and a half coming up with this nice new algorithm that you devised to, not use arrays, because we could just use an array to figure out which areas are covered by which count. Like it's not that difficult. So we could just, fill in the arrays as needed. We figure out how much of the array is, covered by, and then we return the number that was covered the most, basically. And then, yeah. So I think you'll be a little bit better, easier to explain once I get to the code. All right. Does anybody have any questions about the problem setup? Okay. Concerning a question about the class scheduling, I think it will go. There wasn't anything posted on the Discord, unfortunately, but I would presume it would be pretty similar Monday to Friday, and then yeah. So today until the end of the week, and then next week all the way until the 26th, which is the day before USACO officially opens. So yeah, we would have 9 classes containing me and some other teachers that would show up. Yeah, so that is a good question. I will always. How about for people only doing ACSL? ACSL, the contest to deadline is actually quite distant from now. It's on March 5th, is when everybody has to take it by, in the middle of January. So we have some time. So I don't think they're going to mix the ACSL this time. They might, but they might not. Because when we did it last time, it was actually pretty close to the end of the January contest. Like we were in like, I don't know, like this, like we had a month left before the end of the contest. And like, we all wanted to have you guys finish it like by the end of this, like towards the end of December, just in case some stragglers ended up in January, we'd have some buffer. But we have still quite a bit of time. We have all of February uh, be, before ACSL contest 2 ends. So just yeah, just keep watch. I think it will be mentioned if there is an ACSL class. Yeah, it will be explicitly mentioned that, oh yeah, today we will be having an ACSL review or whatever. Yeah, so does that answer your question? Oh, okay. Yeah, no problem. So in that case, we will go and go and do the problem. Again, this one isn't that difficult. So the main challenge is just in like, the main challenge is just in programming it. So I'm going to go ahead and use the same template again. It might help you if you have a USACO template ready to go. There's like an empty Java class that contains like Java that imports and then sorry, public static void main and scanner. But it depends on what you like to do. Good. Uh, public class. Question name is Lifeguards. I have to turn the colors on. There we go. That's colorful now. So let's see. We need a public static void main, string cards. Let's see. I would need a scanner, so let's make a scanner. S equals new scanner. A new file. I keep using the system.in, which is you're supposed to use for this contest, but I don't know. They just changed it for some reason. It's called lifecards.in. Print writer out equals new print writer. This is very tedious, and I can't spell things correctly. Okay, so there we go. So yeah, this is a reason why you might want to have a template like just this part so that you don't have to keep typing a print writer out equals new print writer because I see you have to write the same words over and over again, which is something that's very tedious about Java. Anyway, we have n counts. So let's make int n equals in oops, that next int. I'm used to writing in for some of my input things. So I write in sometimes, but I always call my scanners S. And then let's see I'm gonna pull up the problem. So each of the next n lines describes a lifeguard in terms of two integers in the range 0 to 1,000. So let's make two arrays, a new int that contain their starting times and then ending times. So that way they're paired. So index one of start and end are both paired, so like they refer to the same count. We will go and do that. Int I equals 0, I is less than n, I plus plus. We will do a start of I equals s dot next int end of I equals s dot next int. All right, so we've already read all our input, which is very nice and very convenient for all of us. And then what we'll do is that we will have an array int int. Let's what should we call it? I'll call it covered because we want to see when the lifeguards are gonna cover it. And then yeah, we will call it covered equals a new int. Let's see, we call it 1,001 because we are actually interested in, we are interested in figuring out which of these moments are, which of these moments are being covered, basically. So we're going to try each cow out in sequence. We're going to try removing each cow and adding each cow back in. And again, this is not the most efficient algorithm because I'm sure there's others that like I'm sure you could do it. There is an algorithm where you could do this in one pass and it's all very convenient. And there's another way you could do it without having to reset the int array each time. So yeah, there is a way you could do it, but I'm just doing it the simplest way possible. So I'm going to do for I equals 0, I is less than n, I plus plus. I'm going to make a new int array each time. So you just have to remember what the variables mean because I does not tell you a lot by itself. So I'm going to say I stands for the cow that we remove. So we're going to try it. We're going to try int j equals 0, j less than n, j plus plus. If j is equal to I, we will skip that cow because we pretend that we fire this cow. We're just going to do continue. Otherwise, we will do for int, and I just realized this could be kind of nasty in terms of, this could be kind of nasty in terms of performance. I forgot to take into consideration that there could be cows that I forgot to take into consideration that I would also have to make a for loop over here to fill in the array. Ooh, okay, that is a bit of a problem. But we'll see how well it works. We'll see. If it doesn't work, then we'll try a different way. And then if it does work, then it works. We'll start of j and then k is less than end of j and not less than or equal to, but just less than. K plus plus will do covered of k equals 1. And then we will count up how many elements there are. And I just realized how inefficient this solution was. J plus plus. Luckily, we have some time before 10 o'clock. So if this doesn't turn out to be the best way, I will figure out a slightly more efficient way of doing this. So If so, this you don't have to write an if statement for this. Actually, you could write count plus equals covered of k. The logic is that we always set covered of k equal to 1, or it's either 1 or 0. So if it's 1, it will add 1 to the count. If it's 0, it won't add anything to the count. So you don't actually have to write if covered of k equals 1, then count plus plus. You don't have to do it like that. So we will do, actually, let's put the count inside. And then you'll do max count equals 0. So we'll do max count equals math.max. Max count equals count. We'll do, and then we'll do out.println max count. And also we do need to put out.close. That's what I forgot to put at the end here. I'm forgetting a lot of things, but you do need to put out.close at the very end. Again, if you are here with me on the last sessions, you would have told you that out.close is like you save the file before you close it. It's like you typing an essay in Word and you close it without saving it. So let's go. I'm gonna save this file, and then let's see how it works. And then I'm going to compile this. Do let me know if anything doesn't work. Like if you get syntax errors. Oh, and it should be J over here, not K. Simple typo. Oh, and I should put throws IO exception up here. Okay, so it looks like it compiles without issue. So let me pull up this problem in my browser and submit it. Oh, okay, I already submitted this problem before at some point. I don't know when I've submitted it though. It must have been a while ago. But anyway, so this is a possible solution, one that's possible. Let's see, looks like. Okay, so all of them work for this one. It's not particularly extremely efficient, but it works for all of these. Yeah, so that was a little bit of a seats of your pants coding right there. Yeah, so hopefully this makes a little bit, hopefully this shows you that this kind of problem is not that difficult. Like I would say it's very similar to the first problem in Bronze 2022 December. The one where they're like cow salaries and or cow tuition, like that. So your goal with these problems is to consider them easy points. They're like if you've ever been to contests like Code Wars or Code Quest, you would have seen that the problems at the very beginning are worth very few points, but they're very easy. They're like system.out.println your middle name, and then that's what you have to do. But those are easy points, so you don't want to waste any time getting them. And the faster you do this, the more time you leave for other parts of the contest. So I will put this on Discord in a little bit. Let's check this one. I'm going to double check it. I'm going to make sure it compiles. Oh, okay, it compiled first try. So I did not actually make any syntax errors on this one, which I'm very proud of actually. So let's see. I'm going to submit this. I'm pretty sure this should work. Oh, okay, I already submitted this one in the past. So let me upload this real fast and I will see if it works. Yeah, so your goal here is just to finish this as fast as possible. You do not need to make a world like altering, like groundbreaking solution. for this. Like, yeah. Ooh, okay. Bill Billboards dot out. Oh, what's this? Oh, I did the wrong. I submitted it to the wrong contest. Yeah. Okay. But anyway, your goal is to then finish this as fast as possible. I have seen a pattern emerge in like USACO. Like one problem is going to be easy like this. One problem is going to be more moderately challenging. And one of them is going to be very, very difficult. And I just realized this does not produce the right output. Uh-oh, that's not good. Let me analyze this real fast and I will. Oh, okay. It should say J over here. It should not say I. It's my bad. Yeah, I said J. I said I. This is the problem with copying and pasting. If you do it, you might forget to change a couple of things. Like I forgot to change I into J, and then yeah. So I am curious. Okay, yeah. So this is the and all of this works. So I am curious what your guys' experiences were with USACO on in December. How did you find it? Okay, well, okay, that's one way to sum it up. Yeah, somebody said it was hard. Yes, it was difficult. And then anybody else? No? Okay, it was hard. The thing is that these problems have been getting harder and harder over the years. So yeah, they've just been getting harder and harder and harder. So unfortunately, so at some point I think that we will go over or if we aren't, I will try to petition them to add the 2020 December problems just so you could see how to solve them because they're the most recent ones. And then yeah, so I think it's worth being able taking a look at them. But today is not the day for it because it is 9:53. We have written both problems. I'm going to stick them on the Discord. I'm going to stick this video recording on Discord as well. So you could watch it at your leisure and watch me ramble on about these problems for the better part of an hour. All right. Does anybody have any questions? No? Okay. Then I guess I'll see you later. I might see you tomorrow depending on who's teaching tomorrow. So yeah, have a wonderful evening and don't forget to try these programs at home. Like don't forget to retry it, try to come up with slightly smarter solutions. Because yeah, these are not very smart solutions. Yeah, if you have any questions, please stay. If you don't, then I guess you're free to go.
I had a question about I made a solution for the first one, the build or
The billboard.
yeah.
Well, let me actually
Uh,
stop recording.